Presented here is the Prater fine grinding mill. The Prater fine grinding mill is ideally suited for pulverizing brittle, free-flowing materials into fine powder. All mills are built onto a raised base as shown and intended to operate using pneumatic air. Pneumatic air is utilized to control dust, minimize temperature rise within the mill, and to transport material from the mill to a collection point. The Prater fine grinding mill includes features designed for reliable operation and ease of maintenance. Some of these features include an externally mounted spindle with maintenance-free bearings. Mounting the bearings outside the grinding zone protects them from becoming contaminated with processed powder. The bearings are sealed within the spindle housing using mechanical air-purged seals. Incorporated within these seals are brushes that eliminate the buildup of static charge within the machine. These brushes provide a means to connect the grinding rotor and shaft to earth ground, thus reducing the possibility to ignite dust within the grinder housing. Another feature is the large door that permits full access to the grinder's interior. The door is mounted on a slip hinge that permits one-hand operation and eliminates binding of door on the hinge side. This ensures the door will clamp flat against the housing, creating a positive seal during operation. On the inner face of the door are two concentric O-rings. The larger O-ring seals powder within the mill housing, while the smaller O-ring seals unmilled powder within the grinding chamber. Inside the mill housing are two main components: the grinding rotor and screen frame assembly. The rotor contains high-strength alloy blades that are easily replaced. Likewise, these blades are reversible within the rotor to provide more even wear and longer part life. The rotor itself is easily removed by unfastening one bolt at its center. Similarly, the screen frame is also removable by unfastening 3 bolts at the back of the machine. To ensure safe and easy handling, all grinders include a skirt and rails below the screen frame. The skirt and rails help support the screen frame during removal and installation. Likewise, the interior of the mill body includes a machine register designed to properly center the screen frame around the grinding rotor. The Prater fine grinding mill operates on the principle of high-speed impact. Material is delivered to the machine through the center of the door in controlled fashion. A T-inlet mounted to the door includes a vertical tube for introduction of material and a horizontal tube for air. As material falls into this T, it mixes with the air, which fluidizes and transports the material into the grinding chamber. As material and air mixture enters the grinding chamber, the high-speed rotor accelerates particles outward, where they are impacted against the face of the grinding blades. The screen frame is held in close tolerance around this rotor, ensuring the particles are properly sized before exit. Serrated jaws mounted within the screen frame amplify the grinding action by creating rapid deceleration of the particles and shear as they are reaccelerated by the rotor blades. Once sized properly, air helps evacuate particles from the grinding chamber, where they are transferred to the convey system by means of a discharge transition mounted under the machine. In our next video, we will show you how a grinder works within a typical pneumatic conveying system. Shown here is a typical pneumatic grinding system in Prater's test lab. Every pneumatic grinding system will include a feeder to control delivery of material to the system, a milling machine for size reduction of particles, a filter receiver to collect the product and separate it from air, a fan that creates suction within the system, interconnecting piping to control movement of particles along a desired path, and a control panel to start and stop connected equipment. The advantage of a pneumatic grinding system is the control of dust, ease and flexibility of installation, and reduced handling of material. Because this system operates under a vacuum, all dust and particulates are drawn into the system through inlets designed to receive material and air. Similarly, if there is a leak within the system, air will always move into the system, preventing material from leaking out. As you can see here, the grinding system is set up in an L. The fan and filter are located along one wall, with the mill connected at 90 degrees to the wall with piping and elbows. In most cases, the use of convey pipe and elbows will permit full flexibility to lay out these components in any shape the customer requires, taking into consideration the available space, access to the room, and staging of raw goods and finished powder. Utilizing this type of system, material handling can be minimized, allowing operation by a single person. In a typical production mode, the operator would turn on the system by pressing a start button on the included control panel. This would initiate a sequence of events that turn on all control devices in proper order. Shown here is another system within our lab that shows how the feeder and mill are connected. Once all the equipment is in operation, an operator would fill the feeder with material, which is located next to the mill. For safest operation, the feeder hopper will be located at floor level, minimizing the lifting of materials. Once the feeder is full, it would begin delivering the material into the mill. As new material is delivered into the mill, pneumatics carry away milled material at the same time. Pneumatics carry this material into a filter receiver. Ground material is separated from air in the filter receiver vessel. This vessel includes replaceable elements woven from a highly efficient polyester filtration media. As material is collected at the bottom of the vessel, it is discharged through a rotary airlock. The rotary airlock keeps the system sealed while simultaneously discharging powder. The filter discharge is often raised some distance to allow installation of accessories below. These accessories can include other pneumatic systems to carry milled powder to other parts of the plant, screeners as shown here for grading the material based on size, or even a bagging system that can collect material into the customer's packaging. Quite often, the same operator who loads material into the system can also manage the bagging operation. At the end of the system is the fan. The amount of air moving through the system is easily controlled by a damper located at its outlet. Opening or closing this damper will increase or decrease the volume proportionately. Back to our original system shown, this particular one operates on a floor space approximately 12 foot wide by 10 foot deep by 20 feet high. Smaller and larger systems are sized accordingly to suit a wide range of capacities. In summary, the Prater pneumatic grinding system is designed for efficient, reliable, dust-free operation.